Hello, good morning. My name is Paul Merrill. I'm from Beaufort Fairmont Automated Testing Services, and we work with teams to transition over to automated testing. We do that with teams that are in agile environments as well as traditional environments. Today, I'm here to talk to you all about the data that we use for testing and how we manage it. So I generally like to start out with a question. The question today we're going to ask is, why do we care about the data used in the system under test? So maybe that's something you can think about for a few minutes. I usually get a number of different answers when I ask this question. One of the answers that I get a lot of times is that the data that we put into the system dictates the data that we get out of the system, or it has some impact on it. And that's very true. So that's one of the reasons that we may care about the data that we use related to the system under test. Another response that I tend to get is that we don't necessarily know what to expect the system under test to do if we don't know what's in the system under test, the data that's in the system under test. So maybe think about that question as we go along with this. Today I'll be working with you here through GoToWebinar, so you'll see me looking off to the right here sometimes where my other screen is to work with some of the control panel and that type of thing. And I look forward to getting to know each of you. I know that this is a recording. The live session was back in late September of 2016. We try to do these monthly, so make sure to sign up. If you're watching this right now, we'll automatically sign you up for our newsletter or notifications about this, and you're welcome to unsubscribe at any time safely. Once again, my name is Paul Merrill. I'm a principal software engineer in test at Beaufort Fairmont Automated Testing Services, and my background is in software engineering. So I started this journey of software engineering back in 2000. My first team that I worked with in agile development was in 2002, and my first automated testing was also in 2002. And since then I've done a lot of different jobs relative to software engineering, and I have a pretty significant broad and deep understanding of the technologies and the implementation of these organizations and the products that they create. So today let's back up. Let's talk about data strategies and how we manage the data under test. So what we're going to do is we're going to go through and define terms. First, we're going to talk about what we're going to talk about. Then we're going to identify constraints and talk about what constraints are and how we use them in defining our data strategy. And then we're going to walk through specific examples of data strategies. So let's define terms. First, a data strategy is the combination of code, procedure, and infrastructure that affect how tests interact with data to stimulate the system under test. And I'll refer to that as SUT several times throughout this presentation. This has been my working definition of data strategies as I've gone through this presentation and put this information together. A little information about how this happened. I sat down and wrote down all the things that I would have wanted to know as an automation engineer when I started and kind of put it in an outline. And then I picked a piece of it to dive into very, very deeply for you all and for myself. And my favorite piece to dig into was this data strategy. So what I did was I took what I knew about data strategies and what I knew about setting up and cleaning up the systems under test and the data in them. And I took that information and dove into it as deeply as I could, and then took it out to a local meetup group called Triangle Test and Automation Users Group. We have a really good meetup area here in North Carolina in the Triangle area. Lots of networking goes on. There's lots of tech companies here, so we get to know each other. We can bounce ideas off of each other and kind of do peer review and that kind of thing. So that's what I wanted to do with this presentation. So I put this presentation together and put some working definitions together and took it to them and got a lot of really good feedback there, and I'll appreciate that for a good amount of time. Now I'm writing on data strategies some, so make sure to look for that as it comes about. But the first term we've defined here is data strategies. It's a working definition. Please reach out to me if you have considerations for this definition or ways that it can change and be better. I'm always looking to learn more and to sharpen my thinking about this and other things. A constraint. I'm using the definition here that a constraint is a characteristic that applies a force in a way that is limiting to an automated test or its environment. As I was going through what constraints are, I realized that there are several abstractions that we can use in talking about constraints. So some of the factors that we use in defining what constraints are and building them, the pieces of that, are policy. These are things like internal and external regulations. Cost, this is both your labor and your capital expenditures. Infrastructure, this is both your technical infrastructure and your ability as an organization to do something. And then people. People like things, they don't like things. They are a major factor in identifying constraints. So let's do that. Let's identify some constraints. So here are a few specific ones that may be familiar to you. Shared environments, downtime, technical skills, data source growth, repeatable tests, and data variance. These are some of the ideas that we constrain our thinking about our systems under tests. And I've listed next to these the factors involved in them. So for instance, and I'll only go through one of these, and hopefully you can look at this slide later on or go back through this recording or just pause it to look at these individual ones. But specifically for shared environments, usually when people are implementing shared environments, there are a few main considerations, and they're built upon policy. So for instance, maybe there's an internal or external policy dictating how you can share data and where you can move data, and that may influence your decision to use a shared environment. Secondly, cost may be a consideration. So cost is always a consideration, right, for most of us. But the amount of labor and the amount of costs in setting up a shared environment may be less than setting up environments for each of your testers or for each of your developers. That tends to be a little different these days, and that we can deploy very easily with lots of really great tools to the cloud. So shared environments may not be as big a consideration today as it has been in the past. Infrastructure is a big piece of the equation here. What do we actually have technically and hardware-wise in order to deploy our applications? And also, how is our organization set up in order to deploy applications and maintain them over time? So those are a few of the factors involved in shared environments. Hopefully, by going through that, you can get a sense of these other specific examples of constraints and the factors involved in them. So let's talk about specific examples of data strategies, and let's start with kind of breaking it down. So at a fundamental level, data strategies have two parts. The first part is a creational strategy, and this is how and when the data is created. The second part is a cleanup strategy, and this is the method by which a data source is returned to a benign state. We don't always want to delete the data that we created. Sometimes that's more cumbersome or more technically challenging than we'd like. So I use the word very intentionally here, the word benign, to talk about the state that we get the system back to after cleanup. So let's talk about the first approach that most folks use when creating automation and when testing originally. Basically what we do is we have a test case, and we'll go out and say, okay, what data do I need in order to implement this test case? And generally we'll look in the system under test for a specific piece of data that we can use as an input or as an expected output to have changed. So that's kind of the elementary approach. The creation, the test assumes that data is specific to what you need it for. We look for specific data in the SUT to use. There is no creational strategy. And cleanup, there's basically no cleanup strategy either, no management of data. The idea here, think about the first test that one might write, and let's use a specific example. So maybe this is a little more easy to grasp. Let's use the idea of checking to see if a password changes. That's something that should be familiar to most of us. So let's say your system has a login, and in order to do a login, you have to have a user. So behind the scenes, you go out and find a user and a password. You enter them into the login screen as the first steps in your automated test. You click on submit. You're logged into the page, and you go into the profile section of the page, go to the drop down for change password, change your password, click on save, and you get a nice verification there that says yes, your password has changed. And then the test is done, right? We've gone through all the steps to change a password and we verified it. But what are the problems? Well, the problems are that this won't work a second and third and fourth time, right? So that means, well, what has happened? Well, we've gone through and changed the password. So the next time you log in with it, if you've hard-coded the password into your test or test script, you won't be able to get into execution number 2 and execution number 3. They'll fail on the verification. They'll fail before verification because you won't be able to log in. So that's what I've tried to kind of show here, is showing that execution number 1 is blue because that execution of this particular test case worked. Going down, execution number 2 wouldn't have worked, nor would have execution number 3. I'm showing that these executions are going against the system under test, and that the system under test is interacting with a data source. And I call this a data source because it could be a file system, it could be something in memory, it could be a third-party application that provides data for some reason, or it may be a database. So in each of these slides, when I've referred to the place where we store data, I mean, it could be a data warehouse or a data mart, something like that as well. But each of these cases, I wanted to refer to that abstractly, just like we're referring to executions and systems under test abstractly here. So there are pros and cons to this approach, and one of the pros is that there's no implementation, and it's very simple. It takes very little time to get set up. You don't have to write a data strategy for this. There's no work whatsoever in that. The skill set for that can be very low. You don't have to hire specific technical skills or go find a specific technical skills within your organization to do this. The cons, well, it's not repeatable, right? You can't repeat the test case. There's no isolation of data, meaning you're using data, you don't know if anybody else is using it or any other tests are using it, so that data is not isolated between test cases or between individuals doing work. And it doesn't work on different systems. So let's talk about what a lot of folks do the next time around. So as we grow in our automation and as we grow in our careers and our technical know-how, we try these things again and again. And we try different things. And what I've noticed is people tend to try the same things in about the same steps, the same sequence. So refresh data source tends to be the next approach, and it makes a lot of sense, right? So for creation, what we're going to do is we're going to assume that specific data is in the data source, just like we did on the elementary approach. And then we're going to, on cleanup, manage the data by refreshing the data source. So this may mean that you do a snapshot of your data source if it's an Oracle or SQL, SQL Server database. Maybe you do an export or a snapshot and you save that off somewhere, and prior to your next test cases running or after your last test cases, you import that data or refresh that snapshot, and that gets you back to a state that you know and that you can work with, where all of your data is back to the state that works best for your test cases. So that kind of looks like this. Before each execution of a test or a test suite, we're doing this data refresh. Each of these are happening, they may be happening against, we're still executing against the system under test. Your refresh of your data is generally going to happen directly against the data source. And that's why I have this little symbol of what looks like a data source and the circle refreshing it here. So before each execution or each test suite or each job of running your tests, you're going to do this refresh. So obviously there are some pros and cons here, and hopefully you're already seeing some of those. These are the ones that I've listed. There can be a big time issue here. If you're refreshing a database like a large database or data schema with lots of data in it from Oracle or SQL Server, it may take a significant amount of time to run that refresh. Usually there are significant technical skills needed in order to create that refresh in a way that it's a one-button push, or you can call it at the end of your test jobs. Some of the pros, on the other hand, is that it's uniform. You can use it again and again and again, and you can, once you write this, you can use it across different databases or data sources. There's less time and cost to implement this than some of the other approaches we'll see. So you've read through these by now. There are some pros and cons to this, as there are to each of these approaches. So let's talk about the next approach. Refresh data source is one that you've probably seen before if you've done much automated testing. I'd love to hear stories about how you use it and how it works well for you. I've heard of some products that use virtualization across databases that can be very helpful for this sort of thing, and actually cut your time to restore databases or get back to a known state from hours down to just single-digit minutes. And I'm more than happy to talk about those products sometime, but I don't want to kind of promote one or another right here on a recorded webinar. So feel free to reach out to me. We don't provide any products like that. We're a services company at this point, so we're happy to talk through those with you and help you choose one that works well for you. So the next approach is called selfish data generation. Basically, test cases or test suites generate the data that they need when they need it. There's no cleanup whatsoever, and that's why this is called selfish. So what we're doing here is basically a test creates the data that it needs. It checks to make sure that that data has been manipulated or has caused certain responses in the system, and makes verifications on that. And later on, we come back and we don't do any cleanup. So the data sits there. We always create new data, so we don't really care about the old data. So here's kind of a, excuse me for just a minute here. Here's kind of a diagram of what selfish data generation looks like. And I'm using the new document icon here to talk about the executions here. And these may be test cases, each one of them. They may be test suites, or they may be a job. Maybe it's an entire job where you can create all the data you need before that job or test suite and run the tests based on that. There is one assumption here, that is that when we create the data, we're creating unique data that we can use in each of these executions. We are doing this, the execution still against the system under test. Now, the data that we create, maybe we create it through the system under test, and maybe we create it directly in the data source. Those are options for you to figure out. Generally, it's much faster to create the data at runtime. It's faster to create the data in the data source or against the data source, as opposed to going through the system under test. But there are some pros and cons there as well, right? So if you're going to try to create the data directly in the data source, you have to know a whole lot about the data model and the data schema in order to do that, or whatever mechanism it is that is your data source. And if you're going to create it within the system under test, you're probably going to, it's probably going to take a long time to create that data, meaning you're going to have to go through a UI or an API to create the data, and then once again, you're trusting the application that you're about to test. So those are kind of a couple of the big pros and cons. I've written down a lot of the other ones here. Please feel free to just pause this and read through these as you see fit. But basically, one of the big pros is that there's not as much downtime as the refresh data source approach. And that can be huge depending on how your system is set up and what your specific needs and constraints are. But it requires a big understanding of the data model. That's one of the cons here. And you also have unchecked growth of the data source, and that can be a problem if you're creating a lot of data. In fact, you don't even have to create very much data at all for this to be a problem. I've been in situations where my tests have created a large amount of data very, very quickly, and it impacted more members on the team and took their time. So when using this approach, this is not necessarily one that I would recommend you use in many situations. There might be specific situations, like if you want to know how your system reacts to the buildup of data very quickly. You run these tests again and again and again, they're going to create a lot of data, and you're going to see very, very quickly how the system reacts, what gets slow and what doesn't. One of the things that happens very often is we see that queries get slower over time. Pagination issues show up in UIs. So if you want to uncover some of those issues, maybe this is something that you can approach it with. If you just have not yet gotten to a point where you know how you're going to clean up data, maybe this is an approach, provided you know the data that you created, and we'll talk more about that in just a moment. So let's talk about how we would clean this up. So one way to clean it up would be with a batch cleanup, meaning at the end of all of our test cases, or at the end of a specific, at the end of all of our test cases, our entire suite or our entire job, we're going to do a cleanup of all the data that we created. Maybe that means wiping out a database and starting over. Maybe that's okay in your system. Generally, it means having some type of script that can go and recognize the data that you created and delete exactly that. So batch cleanup looks something more like this. It looks very similar to the data generation, the selfish data generation idea, in that we're creating data before each execution, either before each test case, inside of each test case, where it's needed or before each test suite. And then we've got this new cleanup happening down here at the bottom of execution number 3. So after all of your executions, and I'm just using 1, 2, 3 here, you're really execution in, maybe that's the way that I should specify this here to be a little more clear, but at the end of each of your executions, you're going to have, at the end of all of your executions, you're going to have a cleanup. And that cleanup may happen within the SUT, although I don't necessarily recommend that. Most of the time, it's going to happen in your data source and across your data source, and that makes it a little bit easier. Hopefully you see what we were able to do here. So we're limiting data growth by introducing some type of cleanup, so that's a good thing, that's a pro. One of the things that we're doing here is we're hopefully we don't have stale data anymore. If that's a plus in your organization, that's a good thing. Feel free to read through these and pause and just kind of ruminate on what each one of these means. The cons here, you know, it requires a deep understanding of the data model to do this one, because many times the batch cleanup is going to happen directly against the data source, and that means you have to know exactly how the data source is set up, its schema, how things are affected by your changes, and you can't just go deleting data in every single data source out there. So make sure to be in contact with someone who knows the schema very, very well. Last thing we want to do is create more work for ourselves out of not having a few simple conversations with those who know the data schema. On the other hand, this can be a really great way to push forward incrementally in maturing your testing and automated testing. It can happen with one button press. It can be very, very productive. I've seen this be very, very productive before. So let's talk about the next one of these, and the last one that I'm going to leave you with today, the last approach, which is data generation and immediate cleanup. And what I mean by that is that tests generate their own data, once again, either prior to a test case, prior to a test suite, or within a test case. We create only the data that the test case needs. And then immediately at the end of that test case or test suite or some hybrid combination of the two, we're going to clean up the data that we created. And there are two parts to this that I think is easy to overlook. There is the data that you knowingly created in your test case. These are usually inputs into the system. And then there is the data that you don't know is created, the data that's created indirectly by the application as a response to the inputs you put in. And that data can be much harder to get at. I'll give you an example of how I've implemented this in the past. One way was in a .NET framework. We had a very nice RESTful API we were interacting with and testing against. And with this API, we were doing the data generation creation strategy here. And we wanted to do immediate cleanup. When we started out, of course, the first thing you think about is let's clean up the data we knowingly created. And that was easy. You can keep that in a list or outside of your test cases or wherever you think it should be, and we're going to talk more about that in just a minute. But we needed to know what to clean up, and we needed a good way to clean it up. And it was very easy originally just by creating a list and going through and deleting that list and doing cascading deletes in the database and all that. But if there are no cascading deletes, if there are no foreign keys, it's hard to do a cascading delete. And depending on your data source, you don't necessarily know how to delete that data. So what we did to get at the data that was created indirectly by the system under test was I overrode I'm trying to think of the name of it, the entity framework's saved mechanism. So we were using entity framework 6, and the actual class escapes me right at the moment. But we overrode the save changes method in the class that saves and interacts with the database in entity framework 6. And we had a factory that would create the proper data model each time we needed it in the application, and we used that factory to get the right one of those. So in the test situation, we used the test data model, and in the production system, we use the production one. And by doing that, we call the proper save changes for each of those. Feel free to contact me later about that if you want more information specifically. And maybe I should write a little bit about that as well on my blog over at beaufortfairmont.com/blogging. I know that I didn't do a great job of talking through that there, and I'd be happy to speak with you at another time about the specifics of that. But basically, we were able to isolate what was created by the system under test and what was created by the tests and clean up everything with very few exceptions. Let's talk about the pros and cons of this. It takes a lot of skill to be able to do this, more than most testers, I guess, would be able to sum up. Testers that have a strong background in software engineering certainly would be able to handle this. Software engineers can do it as well. Many times teams will rely on their software engineers to create APIs or endpoints or services that can create data for them and do the cleanup of that data and any data that may have been created because of the tests as well. So there are a lot of different ways to move roles around. Certainly one of them is to bring in expertise like we are at Beaufort Fairmont. Cons here, you have to have a deep understanding of the data model. You must know what to clean up, and the infrastructure is non-trivial to create. So when I first gave this talk, the talk ended at that last slide. Now it goes into these next two slides, and that's because when I first gave the talk, I felt like I was telling a joke without the punchline. And I feel like this is the punchline. This is the slide, this one and the next one are the slides that can hopefully help you determine which strategy or strategies to use in isolation or in combination to work with your particular environment. So, for instance, if downtime is a concern to you, certainly the elementary approach would work. So would data generation. But the refresh approach generally requires downtime, so you wouldn't want to use that. If significant skills are something that you don't want to bring into the team or cannot bring into the team or don't have on your team, then you're going to have to use something like the elementary approach for creational strategies, as opposed to the refresh or generation if you can't find a way to outsource those to other teams or find someone on your team to learn enough to move forward on those quickly. So that's kind of the way that this chart works. Let's move on to cleanup strategies. And in the cleanup strategies, we're looking kind of at the same type of thing here. Feel free to pause this and look through this later. One of the big things we wanted to talk about is how do we know what data to clean up, and I have a couple terms to talk about there. One is by signing the data. So like your signature, when you write out your signature, it's a very specific, unique thing. So you can actually use the data to determine that this was data that needs to be cleaned up. Another way would be by creating columns in your database or in your data source that are actually is test data, and so it's a flag for a particular data. One of the cons there is that you have to do it for everything. You can use persisted data, so you could keep a list in a data source, but then if the test case dies from a runtime exception, you've got issues there where you've leaked data and you haven't gone back and cleaned it up. So to review, we've gone through terms, we've identified constraints, we've walked through examples. These are a few of the references that I need to put out there for the Noun project, which are the icons that I use. These are the folks that created them, and this is how I'm able to use them freely. The Noun project is awesome. Make sure to call me, and let's talk through what your challenges are with data or whatever. I've got a podcast on software engineering and also entrepreneurship called Reflection as a Service. Please check that out. Put it in your podcatcher. We're on iTunes and all of the other major podcast delivery mechanisms out there. I write at beaufortfairmont.com/blog, and here's my contact information. I'd really like to get to know you and what your concerns are and how you're working with data in your test systems. Once again, Paul Merrill from Beaufort Fairmont Automated Testing. Thank you so much for your time today.